Is our last video in this little set talking about solutions. And what we're going to get into today on this video is concentration. Okay. Now in Gen Chem 1, we talked about concentration and we focused in on molarity. And molarity is moles of solute per liter of solution. So we really want to remember that. Remember, this is capital M, and every time we see the capital M, excuse me, I want to think this is moles of solute over liters of solution. Okay. Um, the way you would make a solution, and you guys are going to do this, oh, you're going to do this? You're going to do a dilution into a solution, but yeah, but typically the way you're going to do this is with a volumetric flask. Okay. So here they want to make 1.00 molar NaCl. So what they do is they weigh out 1 mole of sodium chloride into a volumetric flask. Now the volumetric flask is specific for a particular volume. So want to remember that too. Flask. Okay, and they come in various sizes. So, and when we'll look at this again in a little bit, I guess. You put 1 mole of sodium chloride in there, and then this one is a 1 liter flask. So you fill it to the mark with water and make sure everything gets dissolved and mix it really well. And there we go, 1 molar solution. So if we had a 500 milliliter flask and we wanted a 1.00 molar solution, okay, this is half a liter. So if we have half a liter, we want half a mole. So this is going to be 0.500 moles in 0.500 liters is still 1.00 molar, right? So it's giving us this ratio as we go by it, okay? Now, molarity is not the only way we can do concentration. So there's a lot of different units here, and I was going to kind of give us an introduction to them and work a couple of example problems. Some of these are going to work the same way, and unfortunately, one that gets really confused between, especially in students who are learning to do this, molarity and molality. So molarity is capital M, moles of solute per liter of solution. Okay. Molality is moles of solute still, but it's kilogram of solvent. And this seems weird, but this is going to be useful for us to do things later on. So I want us to get a grasp on this. Okay. So molality, our little m, is moles of solute per kilogram of solvent. Okay. So if we had, say, 0.050 moles of KCl, and we got it to dissolve in 500 grams of water, which is 0.5 kilograms, then this is a 0.10 molal solution of KCl. Okay, so we say that this little m is, don't do that, molal. Okay, and we'll work some of this in a bit here. All right, other things we can do. I just call this concentration by parts, and this covers a lot of different units. One of these we've already talked about is mass percent. Okay, all of these work the same way as percent. And we can do it by mass and we can do it by volume. In each case, this is going to be solute over solvent solution times some factor. And I'm just going to call this square. Okay, I don't know why I chose square, but we're going to do times some factor. Okay, when it's by mass, your factor is 100%, and so your unit becomes percent. Okay, so it's like figuring out your grade. If you get a 92 out of 100 on your exam, then this is 100, not 100%, don't we wish, 92%. Okay, so there's that kind of stuff. Get rid of that because I need more room. But there's also smaller ones, okay? ppm, which is parts per million, and ppb, which is parts per billion. And the only thing that's different is their factor, 10 to the 6th and 10 to the 9th, because 10 to the 6th is a million and 10 to the 9th is a billion, okay? And they all work the same way. So if we had, say, let's say we have 22.5 micrograms of lead 2 plus in 10 grams of solution. Okay, well, remember, micrograms is 10 to the 6th. Okay, so 22.5 micrograms is really 2.25 times 10 to the minus 5 grams of lead 2 plus. Remember, we want to have our units be the same thing. Okay. Yeah, in 10 grams of solution. And so this, oh wait, grams per grams times 10 to the 6th. So this means we have 2.25 parts per million of lead. Okay. You're also thinking, maybe you're seeing this and you're thinking something else here. Well, oh, shoot, while we're doing that. And that is the possibility that you don't have to have the exact same units. You just have to have the correct units. So if you're looking at parts per million, you can do this as micrograms per gram. So we know micrograms and we know grams. So we could say 22.5 micrograms per 10 grams is 2.25 parts per million. Both work. I think this way is easier to remember, but it adds a couple of steps to it. Okay, whatever's going to work for you is the best way to do it. You probably won't see a lot of this, but it might come up in the homework. Okay, and again, this works with grams or milliliters. So if you had, say, 8 ppm benzene in water, then that would be 8 ppm, 8 milliliters of benzene for every million milliliters of water, of solution. Okay. All right. So the one I want to kind of squirrel in here towards the end is mole fraction and mole percent. Okay. And all of these, this is still by fraction. Okay. So moles, although we can do mass and we can do volume, we can also do moles. So both of these are going to be moles of solute. That doesn't look like a word. Solute per total moles of solution. Okay, this is mole fraction, which is given squiggly looking X, and the subscript A tells us which thing it is. Like if you have A and B mixed together, this is the mole fraction of A, right? You have sodium chloride in water, so this would be the mole fraction of sodium chloride. You could also do the mole fraction of water. Okay, the mole percent is going to be our mole fraction times 100. This is the same way, and mole percent doesn't have a nice unit to it. It's just percent. Okay, so that might all be what we're looking at. And we'll look at an example in a minute here too. Yeah, there it is. Okay, so moles over total moles is mole fraction. Moles over total moles, we could do the same thing. Moles of solute per total moles of solution times 100 is mole percent. That's those two things together. Remember, total moles of solution is going to be moles of solute plus moles of solvent. Okay, so if we're given grams and liters or milliliters and pounds, I don't know, whatever, you got to convert everybody to moles and then do this. Okay, so let's take an example here. Let's see, what are we doing? We are doing 5.55 grams of sodium chloride in 36 grams of water. We want to know mole fraction and mole percent. All right, let's take a stab. What am I doing? Okay, yeah. So we got to get both of these dudes to be moles first. Okay, so 0.555 grams sodium chloride, and we know that 1 mole, right? We're going to use our favorite dimensional analysis. Okay, so 0.555 grams, and we're given here our molar mass 58.44 grams is, I'm just going to calculate this out. Okay, 0.555 divided by 58.44 is 0.0094969 moles, and that's moles of solute, moles of sodium chloride. Okay, we also need moles of water, so that's going to be 36.0 grams. And here, 1 mole of water is 18.02 grams. So 36 divided by 18.02 is 1.99778. 1.99778 moles of water. Okay. Together, our total is both of those things added together. So that plus this one means our total is 2.007277. Okay, and this is moles again. Okay, now to get mole fraction, oh shoot, to get mole fraction, we're going to say our mole fraction of sodium chloride is 0.0094969 moles divided by 2.007277 moles, which is whatever that is. That number of moles divided by 2.0 blah blah is 0.00473 because we want 3 significant figures. Okay, there's no units on mole fraction because we did moles divided by moles and the moles cancel out. Okay, if we want mole percent, we're going to take this dude and multiply him by 100, which means we're going to get 0.473%. And this we could say mole percent. Okay. Hopefully that's not too terrible. We can ask questions and work through stuff. This is just a nice summary chart. You need to know this. This is not given. Okay, you need to be able to recognize this. You need to be able to do this. Okay, so hopefully you have enough practice in there to get things in there. One of the more trickier questions to do is to say, okay, what if we have a solution and we want to know what its concentration is in a different unit? Okay, so if we look at this, we're going to say, okay, we have 3.25 molal, that's little m, and we want to know what is the molar concentration. Okay, so what am I looking at? Okay, so we know molal, and molal is moles of solute per kilograms of solution, and we're looking for molarity, which is moles of solute per liter of solution. Okay, we don't even have to know how much stuff we have. We just have to be able to interpret what we have. Okay, so our 3.25 molal KCl is 3.25 moles of KCl in 1 kilogram of water. Okay, and what we want to do is we want to figure out what this is in moles of KCl per liter of solution. Okay, we already know half of this, and half of this is to say that we have 3 3.25 moles of KCl divided by some liters of solution. So we don't know this. Okay, so what we need to know to get liters of solution is what is the total mass of solution? And we can have a hint here because I'm giving us density of solution. Okay, so we want our plan should be we're going to take milliliters of solution and no, we're going to take grams of solution and take that to liters of solution. I don't know why my grams disappeared. Okay, so how are we going to get grams of solution? Okay, well, dang it. We know that we have a kilogram of water, but we know we also have 3.25 moles of KCl. So we got to get this to be grams. 3.25 moles of KCl using our dimensional analysis skills again. And we know that 1 mole of KCl, because I gave us this is not looking pretty, I'm sorry. KCl, here's our molar mass of KCl, 74.55 grams of KCl. Okay, so 3.25 times 74.55 is 242.288 grams of KCl. Okay. Now we want total grams, so we're going to add to, come on, man. Shoot. I have to keep that. And then go back to where I was. I'm sorry that I keep screwing this up. This is the last slide, I promise. Okay, so we got to take our grams of KCl and we need to add to that a kilogram of water. Remember, a kilogram is 1,000 grams of water. Okay, so together this is 2.288 grams. Okay, we need to know liters of solution. So what we're going to do is we're going to take this and we're going to divide by 1. We're going to do a little dimensional analysis here. Take our grams of solution and say for 1 liter of solution, this is 1.132 times 10 to the 3rd grams. Okay, so we'll figure this out. So what do we got here? 1242.288 divided by 1.132 times 10 to the 3rd is 1.0974 liters. All right, I did not leave myself enough room for this, so I'm going to have to squeeze it in. I know what I'm going to do. We're going to get rid of this because that'll be enough room. Why can't I get rid of that? Okay, fine. We're just going to squeeze it in. Okay. So then our final answer then is moles per liter, right? We have it up here. Oh yeah, we have it up here. So our question mark is 1.0974. Okay, and I'll write our answer up here. So 3.25 divided by the liters we just found out is 2.96, 3 significant figures, so 2.96, there we go, molar KCl. Usually they're pretty close to each other. This is okay. They're different because we did different things and we have different units. Okay, so I'm sorry for the screw ups, but hopefully this made sense. If you need me, get a hold of me, find me, ask questions, email me. I hope you're staying warm and safe, and I will see you when we get back in class together.